Alright, so here is the high voltage HEQ. It's going to be going to market very soon, and this is an exclusive first look at what I consider to be one of the best new analog mastering EQs going to market. And I'm going to give you a bit of a backstory behind this unit. Now, my analog mastering chain is a critical part of my process. One of my most treasured pieces in this chain is this commission-built Barry Porter EQ I got made 6 years ago by High Voltage. Now, since that build, I know dozens and dozens of people have been hitting up James and High Voltage to build them the same prize Barry Porter EQ we put together here. Now, they haven't done that because of how involved a build like this is. I've told them many times there's big demand for high fidelity, no compromise mastering grade equipment, and High Voltage are known to deliver on exactly that at a fair price point, namely with their HV EQ. Now, you'll find this EQ in studios like Studio 301, Crystal Mastering, Lacquer Channel Mastering, Mystery Room Mastering, all over the world, and many, many more. Over the past few years, though, High Voltage have been tinkering away behind the scenes, putting together a unit which is feasible to go into production and delivers on a high fidelity, no compromise mastering experience. And that is this unit here, inspired by the Barry Porter Net EQ. So let's start diving in. What qualities do I consider to be great for an all-round no-compromise mastering grade equalizer? The first thing, it should have rotary switches over potentiometers. The second thing is the resolution, or the number of switch positions per band. Ultimately, it has to be flexible in the workflow, and the fidelity of the signal has to be pretty much pristine for a unit like this. Finally, and ultimately, the real decider is, does it sound great? So let's look at switches over potentiometers. Before I actually understood what a switch was, I thought potentiometers or pots with clicky detents were just a result in the design of the knob I was turning, not an actual fundamental aspect of how it was altering the flow of electrical current in a circuit. Now, each parameter on an analog device is a function of an electrical circuit. Each of these functions pass electrical current, and in order to change the value set of how these functions manipulate a signal, a potentiometer, otherwise known as a variable resistor, is most commonly used. A potentiometer is a single variable resistor, and that can vary in tolerance between plus or minus 10%, depending on how it's graded. Now, previously I used a Crane Song IBIS EQ, not the mastering version, and matching the left and right channels gain parameters using pots was a bit of a nightmare because it's hard to reassign, especially on recall, identical left and right settings when each channel has a variance of 10%. And these variances between the left and right channel potentiometers is a workflow nightmare when it comes to mastering. A rotary switch, however, isn't like a potentiometer, which constantly varies in it can constantly vary in resistance. A rotary switch might look the same as a potentiometer, but on the surface it functions very differently, because what it's actually doing, it's switching between an array of hard wired resistors, and each of these regulate a fixed amount. So this is X ohms, Y ohms, Z ohms, N ohms. So these are all fixed points. And what happens is, this is our rotary switch here, rotary switch. What happens is we turn the knob and we get this connection here. It switches into this position and we have N ohms of resistance. Then we turn it again and we go to a new fixed point. And the beauty of this is the tolerance is about 1% or less. Okay, it's under 1% of tolerance between your left and right channel, which means recalling is super easy. So this is one of the things I look for in mastering grade units, simply because the tracking between your left and right channel are super important. Okay, so what I'm going to do for demonstration purposes is I'm going to jump around the desk, wire my JDK R24, which only has potentiometers in it. It's a dual mono unit I used to use for mixing a long time ago. And what I'm going to do is I'm going to do a 3 o'clock or 6 decibel boost at 2 kilohertz on each the left and right channel. And then in Plugin Doctor, we can actually plot this in a graph to see how accurately the left and right channel track together. Then we'll do the same with the high voltage Barry Porter EQ, which I was doing yesterday with James in, and it tracks perfectly. Like, the curves look like you're working with a digital FabFilter Pro Q3. This matches the left and right perfectly. pots, not so much, but I think it's worth showing you guys this in practice. Here is the JDK R24, the left and the right channel, all with pots. Now, what I've done is all the gain at the moment is at unity gain, okay? At unity gain, which isn't the 0 position or the maximum position, there's about half a dB of variance between one band to the next. Now, let's do a 3 decibel boost at 2 kilohertz, and you can see the way that matches up. It's all wonky. It's quite peculiar. I might just see if I can get all these pots into like a 0 position. Okay. Still, even then, as in the other bands, I just tried to zero out the frequency pot, so the crossovers weren't affecting it, but there's still a lot of variance. And if I go to boost it, let's say 9 decibels, oh, it's a bit closer at 9, but let's try and do a 1 decibel boost. Sort of just trying to match it up there. And there's about half a dB of difference between the left and the right channel. And to me, that's not acceptable in a mastering application. Now, let's look at the high voltage Barry Porter EQ. Right, so now let's have a look at the Barry Porter net EQ. Let's see how well the left and right channel track. So let's do a, what do we got here? 2 decibel boost at around 1K. All right, let's have a look at this one. And we'll go in. Boom, look how evenly that matches. That's within 1/10 of a decibel, if not less, they're tracking together. Let's do a boost in the low end. Perfectly tracking together. What happens if it's a cut? Let's have a look. Matches perfectly. We'll do our high pass filter. We'll carry that up together. Actually, we've got to put them in. Perfect. Matches perfectly. Okay, see that? That is 2 resistors. They're identical resistors in the left and right channel, so they're always going to match up. As opposed to the potentiometers in the JDK R24, you can't use that for mastering. This, you can. And I get a bit excited about this because it's just simple things people don't understand. I would get in sometimes like arguments with people in forums because I would call these switches, rotary switches, and they're like, no, they're stepped pots. And it's like, no, a potentiometer is a variable resistor. And even if it's stepped, it's still that one winding of the resistor. It's just, no. Rotary switches, potentiometers, 2 different things. One has many different resistors you're switching between. Another one is a single resistor that is varying in resistance as you turn it. So anyway, we got through that rabbit hole. Let's keep moving. So now we get on to the resolution, or the number of switch positions per band in this EQ. Now, the resolution of this unit is pretty wild. Standard, there's 4 parametric EQ bands. They're fully parametric, so that means you can control the Q value or Q factor, the gain, and the frequency or the center frequency. Now, of the frequencies, there's 12. It's a 12-step rotary switch for frequency selection on each band. Then there is a 5-step rotary switch for the Q or the bandwidth control, and they also have an option on the fifth position to switch in a high shelf or low shelf for each of those bands. There's high pass filter, low pass filters, all on 6-step switches. Now, the big kicker for this unit, which my unit doesn't have, is that it has 12-step rotary switches for gain, with a 3-way switch acting as a gain multiplier either in half at unity or in 2 times gain, and that provides 36 positions of maximum cut or boost for 2.75, 5.75 and 11 decibels of range. Now, because we're in the electronics rabbit hole, the way this final feed of 36 positions has been implemented is simple yet elegant. So now I'm going to show you the ingenious circuit design. It's simple, it's elegant, it's probably basic for most people that do electronics, but for me it's just magical and I thought I'd share it with you. So 36 gain positions to each of these knobs, okay? Boost and cut, that's incredible. So what is there? There is a stepped pot. So I'm going to do a 4-position stepped pot because I'm not going to draw out 12 resistors in this YouTube video. I'm not exactly an artist when it comes to drawing these electronic circuits. Each of those squiggly lines are a resistor, and a fixed amount of resistance. That's super important to know, and that goes through to a toggle switch. Okay, now that is a 3-way toggle switch, and what ends up happening is each of these positions, or each of these resistors, provide a different amount of resistance to the current. Now, what would that mean? So let's say this is the 1 times multiplier. This would be N amount of ohms, or X amount of resistance. Now, in order to create the boost here at 2x, what do we have to do? Do you have to increase or decrease the resistance? Now, with Ohm's law, amps and voltage are directly proportionally relative to one another. So as one increases, so does the other. Whereas voltage or current and your resistance has an inverse relationship. So we can't increase the resistance here to get more current flowing through. We have to decrease the resistance. So instead of N number of ohms, N over 2 ohms, or a lesser resistor or resistance circuit here, is implemented. And then in order to get the half cut or the half scale cuts, 2N ohms is on that resistor there. Now that's not the exact mathematics they use, but this is just to showcase to you how a simple circuit like this can provide so much resolution in one gain pot. I just was mind blown with this. I actually figured this out and told James, and he's like, yeah, that's exactly how we did it. He showed me the actual diagram of it. It's a little bit more complex than my silly squiggle lines here, but you get the point of what's going on. Workflow is an important part of any mastering chain because being able to manipulate a signal easily with as little friction as possible is important. So I have to address the elephant in the room, and that is the big difference between my commissioned unit being a true stereo unit with one set of knobs for both the left and right channel, and this one being a dual mono. Now, I'll talk about my one here just for a moment. The workflow pros for my true stereo unit is that I can quickly dial in EQ curves for the full stereo signal at any point. The cons though is that I have no access on this unit to independently manipulate either the left or the right channel. The workflow pros of the new one, the dual mono EQ, is that it's going to market for mastering engineers that like to get into the nitty gritty of accessing the left information independent from the right, the mid information independent from the side, and you can do this with the unit. This actually has a mid-side mode, and it's a really unique and great feature for the unit. However, there are some cons to this. When you want to dial in a stereo boost or cut, you need to use 2 hands to key those changes in. I know, that's a first world problem. You have to use 2 hands now to use your EQ instead of 1. But it's something worth pointing out because it is something that changes the way your workflow is. Now, a little Easter egg though, on this unit, which is pretty unique, is something which was developed on this unit when this unit was being built, and it got grandfathered across onto the production of this unit, and it's the ability to bypass independently different EQ bands, similarly to how you can turn on and off an EQ setting in FabFilter Pro Q3. Now, how this came about was when James was building my Barry Porter EQ, he set up a bypass switch for each parametric band of my unit so he could bypass it out of the circuit in tests. Now, when I saw this, I asked if he could implement this onto the final design, so instead of bypassing the whole unit to listen to changes I was making, I can either bypass the whole unit or selectively bypass different parametric bands independent of one another. Now, I'm actually not aware of any other hardware units which do this, so it's super unique and a really good feature. If you've ever seen a hardware unit that does this outside of this realm, let me know, because I'm very curious, because I've never ever seen this implemented on another hardware unit. Now, very important to me, especially in mastering, is how a unit affects the fidelity of a signal that passes through it. Now, fidelity being measured in linearity, harmonic distortions introduced, and inharmonic or intermodulation distortion introduced. Now, on paper, this unit measures flat, and you saw that on the graphs before. The noise floor is 108 decibels A-weighted, and it only has a total harmonic distortion of 0.0030, 8%, 0.0008%. Now, I'm going to show you this in Plugin Doctor so you can see these measurements play out. Here in Plugin Doctor, we can see these measurements play out. Okay, a flat frequency response, and if we go to the noise floor, a low noise floor. Okay, we've got 6 decibels of headroom. Let's do a 5 decibel boost and really get this up against the ceiling at 100 hertz, and barely any harmonic distortion is introduced. And this is namely achieved with its own low noise filtered power supply, and it's just inherent with the Barry Porter Net EQ. It's a state variable filter design which uses no inductors, transformers, or discrete gain stages, which means what you're getting is just purely electronic signal moving through. It's altering the frequencies and then stepping away. We're not using any tubes, we're not using anything that's unnecessary here to the signal. But we've just been talking about it. Okay, we've just been showing stats on a paper. All this mumbo jumbo though, what does it really count for? It's important it sounds great. So I'm going to shut up for a second and we're going to have some fun with it. For the next couple of minutes, I'm going to dial this into a really cool mix. The Colby's, Shadows, it's a big guitar, drums, lots of texture, and we're going to crank this shit out of this unit and really have some fun with it. So without further ado, let's get stuck into this.
When I'm alone, the noise is screeching. The sound of loneliness is creeping. Since you left, I've been in a sorrowful state. Turn Netflix on and listen to block out your gentle whisper. I tell our friends that I'm fine, but I ain't okay. And I want you back in my bed tonight to try fill your empty spot that you left behind. Don't make it goodbye, just lay with me between the sheets tonight. You're not alone from what I'm hearing. The signs tell me what I'm fearing. A sock changed to silence from how was your day. You see, you walked out and left your shadow following round with a loaded barrel. The lonely feeling of change, maybe it's all okay. Then you pull back the trigger singing she should have stayed. And I want you back in my bed tonight to try fill your empty spot that you left behind. So make it goodbye, just lay with me between the sheets tonight. Oh. Her voice roams around, my blood runs through my veins. That kiss.
Wow, that sounded awesome. Now, would we use it to those extremes in mastering? Probably not, but it was cool to see how hard you could drive any particular band and it still held together. The low end was super buttery. Like, you could do some crazy boosts and it just fit together really nicely. Now, before we conclude this video, I need to let you know, this is not a sponsored video. I actually reached out to James as soon as I caught wind that he was putting together this unit because it just excited the hell out of me because I've had so much fun with my unit the last 6 years. The fact that this is going to go to market and other people can have it is incredible. And it's incredibly built. It's got a great feature set. And I know the price point that it's getting released at. I'm not sure if I'm at liberty to say that, but it's incredibly affordable. This will sell straight away. I think it'll be as good a seller, if not better, than the EQ6S, which was a huge success as well. So here's what you should do. Head over to High Voltage Audio. I'll leave their links in the description. Follow them. See what gets released. Okay? Chances are you're going to want this if you need something that's super flexible for your mix bus, if you're getting into mastering, if you need to just have something there for your stereo bus that is high fidelity and incredibly featured, that's an EQ you're going to want to have. In the meantime, while you go and check out High Voltage's stuff and anticipate this release, if you want to see me do more videos like this, I love talking about units that really get me excited. I don't just put anything on this channel. It has to be something I'm using, have used, or I find extremely interesting. If you enjoy these videos, basically, subscribe, all right? Subscribe, hit the like button, share it with your friends. Until next time, take care.